My presentation is on bone histology. The learning objectives are to describe the cellular and extracellular components of bone tissue and cartilage, compare and contrast compact bone and spongy bone, including the function of each, draw an osteon, label all structures and describe the role of the structures, compare and contrast the basic function, location, and lineage of osteogenic cells, osteocytes, osteoblasts, and osteoclasts. Components of bone tissue. Bone cells are the cellular components of bone tissue. Bone cells play an important role in maintaining the bone tissue, which in turn supports the overall structure, movement, and mineral balance within the body. Found throughout the skeletal system, bone cells contribute to the dynamic and living nature of bones. Cellular components of bone tissue there are three types of bone cells, including osteoblasts, osteoclasts, and osteocytes. Extracellular components of bone tissue include organic components, which are collagen fibers and ground substance, and inorganic components, bone salts called hydroxyapatite. Organic components surround the living cells. Collagen fibers provide a surface for inorganic salt crystals to adhere to. Collagen provides stability, strength, and toughness to bones. These crystals form when calcium phosphate and calcium carbonate combine. This creates hydroxyapatite, which is a natural form of calcium on the collagen fibers. This solid ground substance gives bones their hardness and strength. The collagen fibers give them flexibility so they are not brittle. Now let's compare compact bone and spongy bone. Compact bone is denser of the two types of bones. It is stronger but also lightweight and found under the periosteum and diaphysis of long bones. Compact bone forms the hard outer shell of bones, and it also provides support and protection. Spongy bone is lighter and less dense. It is weaker but more flexible and also porous, which is found at the ends of long bones. Spongy bone contains red bone marrow responsible for producing blood cells. Here you will find a lattice-like network of matrix spikes. These are called trabeculi. This forms along lines of stress to provide strength to the bone. The spaces of this network is what provides balance to the dense and heavy compact bone by making bones lighter so that muscles can move more easily. Now we're going to look at osteons. An osteon is a structural unit of a compact bone. It is sometimes also called a Haversian system. It is the functional part of compact bone and provides strength and support structure to a compact bone. Each osteon is composed of concentric rings of calcified matrix called lamellae or lamellar layers. In an osteon, there are osteocytes, which maintain mineral concentration, osteoblasts, which are cells that build bone, osteoclasts, which are bone cells that break down bone tissue, and lamellae, which is concentric rings of calcified matrix. There is also, in the center of the osteon, there is a central canal, which contains blood vessels, lymphatic vessels, and nerves. The central canal, also called Haversian canals, is a long hollow passageway running through the center of an osteon. It allows blood vessels and nerves to travel through to supply the osteocytes. These vessels and nerves branch off through a perforating canal known as Volkmann's canals. These are arrangements that allow blood vessels to enter the bones from the periosteum. Here is a slide about osteogenic cells. Osteogenic cells are stem cells that are found in bone tissue. They play a role in bone repair, bone growth, and healing of damaged or broken bones. Osteogenic cells are the only bone cells that divide. These cells develop into osteoblasts and are found in the deep layers of the periosteum and the marrow. Let's look at osteocytes next. Osteocytes are cells that lie within the substance of bones that are fully formed. This is a primary cell of mature bone and most common type of bone cell. Osteocytes maintain the mineral concentration of the matrix. It occupies a lacuna, which is a small chamber contained in the calcified matrix of bones. Between the lacunae are canals called canaliculi. These are small channels that transport nutrients to osteocytes, expel waste products, and transport fluid to and from the cells. Osteoblasts are located in the periosteum, which is the tissue layer on the surface of bones and in the endosteum. They are responsible for synthesizing and secreting an organic compound of the bone matrix. This ends up mineralizing to become mature bone tissue. As the osteoblast calcifies, it becomes trapped and changes structure and turns into an osteocyte. Osteoclasts dissolve and break down old, damaged bone tissue. This process is called resorption. Your body reuses elements like calcium and creates space for new bones. After reabsorbing bone materials, the bone structure is remodeled.